Okay, so you can find this definition on page 492 in your book, and it will not say E and A. It will say X and Y, but this is the way I like to think of it. Your E is your exponent and A is your answer. So this is what you are accustomed to. Your base, of course, and your exponent, and then you get an answer out of whatever the base and exponent give you. So we're accustomed to this exponent form. What we are about to embark on is logarithms. So at the bottom is the logarithmic form. So you take that base and we do what is called the log of base b to that answer, and what it is equal to is the exponent that you're accustomed to. So you will need to go back and forth between the exponential form and the logarithmic form. So we talk about all of these logs in whatever base. So you're going to refer to lots of different bases. So you can have a base 10, you can have a base 2, you can have a base 3. And what exponent did you use to get this particular answer for whatever base you're referring to? So you're going to have all of these problems where you go back and forth. Can you take an exponential form and write it in the log form? So we've got these two problems. And first, take 11 to the third power, which is equal to 1,331, and it is log base 11 of 1,331, and it's equal to 3, that exponent. And then the other one, which looks a little more unfamiliar because you have 16 to a fractional exponent, and it's equal to 8, because once you raise it to the third power and then take the fourth root of that answer, you will end up with 8. And in log form, it's log base 16 of 8, and you needed the exponent 3/4. So in the other form, if you start out with a log problem, can you go back and write it in the exponent form? So what are you accustomed to? Where's your base? What is the exponent, and what does it come out to? What is the answer? And so you got log base 8 of 512 is equal to 3. So where does that all fit? Well, that would be 8 to the third power is 512. So the next one, how do you write that and fit it in? Well, that would be 5 to the fourth is 625. Now we're going to take that and we need to evaluate. So all of these logarithms, can you evaluate them and come up with an answer? What would be the exponent that you need? So to do that, let's rewrite them in exponential form, and kind of as an equation. So what is the missing exponent? 6 is a little tricky because you have that 1 on top. That means you had a what kind of an exponent to move your number underneath the 1. And then remember 7, how do you get an answer of 1? What exponent gives you 1 all the time? So 13 to what gives you 169? So 13 squared is 169. You get a negative answer for that 2. So how many times do you need to multiply 2 to get 128? And then, of course, anything to the 0 power is 1.